last name. Yes, hi, thank you. I'll be doing the speaking part. David and Tom and others of my collaborators are online as well, because we've all worked together on this project. So, and thank you to the AstroPy booth for hosting us, and welcome to our webinar on how to access Python data, access NASA data using Python. So what we're going to talk about is how to access not just NASA data, but data all over the world using Python. And specifically, we're going to talk about how to use the AstroPy affiliated Pyveo package. So I'm not going to actually run through a code demo today, but I'm going to show you where to find our tutorial materials, and you can run through them yourself offline. But before I do that, I need to spend some time on the background and how it works, because this method of browsing and fetching data has some unique benefits and unique challenges. So the fundamental question, how do we get a hold of the data? On the right, I've listed many of the data sets that we use in astronomy, and on the left is a representation of us, the end user, and the big question mark in the middle is how do we get to the data that we want that are located on different archives with different interfaces located around the world. So one example of how to do this is using the archives portal. This is the MAST portal where you put in a target name and you get back observations and visualizations and catalogs and all the information about the data and ways to download it. Likewise, URSA has its own portal, HEOSARC has its own portal, and NED has its own portal. Since we are the NASA Astrophysical Virtual Observatories Consortium, we're focusing on NASA data, but the point is that you as an astronomer don't really care where the data originated, you just want to get at it. And so not just these 4 portals, but many other portals, ESA portals, ground-based portals, any other archive or data provider in the world will have its own interface. So suppose you're interested in a specific source and you would like to compare all the multi-wavelength data for this source. You could start from the literature and find out what data has been published and then see if you can go find where they're available. And then you could go to each of the different clients and search for your source and click around to browse what's available to get what you need. But this sounds like a lot of work to me, especially the part where you have to learn to use each archives portal and navigate their different interfaces to find the products you're interested in, and then do it for the next one. So what we'd like is for there to be an easier way and one that's scriptable in Python. So you may already be familiar with retrieving data through Python using AstroQuery. AstroQuery was designed to provide a standardized interface so that though the APIs may be very different under the hood in the way the data are stored and accessed, to the user, it's a very straightforward and consistent interface. You put in a source name or position, use a standard query function, and get back an AstroPy table of results. So this is showing the MAST AstroQuery module. And the URSA AstroQuery module looks just the same. So for the end user, it's the same interface. So this is a standardized way to do this through Python, but it still requires knowing which archive has your data and querying them all individually. So what we're proposing is the next step. So suppose you're interested in HST, Swift, Spitzer, and SDSS data for a given source. How do you get all of that? HST is at MAST, Swift is at the HEOSARC, Spitzer is at URSA, SDSS is at NED. What are you going to do? Are you going to visit each of the portals of the different archives individually to see if they have what you want, or use the AstroQuery module for each of those archives? Individually, that is still a lot of work. What we're going to show you today is a better way to do it using the Virtual Observatory. And this is something that you can already use through the archives clients already. So for example, in the MAST portal, you can retrieve not only the MAST holdings, but data available from other archives. This is showing you how you can access the HEOSARC data through the MAST portal by looking at its Virtual Observatory collections. You'll then see the same data you would find on the HEOSARC portal, but through a different archives client. So likewise, you could use the other archives clients to get data from all the different places in the world because of the Virtual Observatory. The VO has defined standard APIs, so the same query can be sent to all VO compliant services. The archives then interoperate, meaning you could download all of this data from the MAST portal or from each of the others. What we're interested in today, though, of course, is how to do this using Python as the client. So Pyveo is an AstroPy affiliated package that allows us to do this. It's a client for all VO services that you can call through Python, either interactively in a Jupyter notebook or programmatically in a scripted batch job. Pyveo itself is an open development project on GitHub that's a collaboration among many different archives, not just NASA, but worldwide, and includes tools for data discovery, catalog searches, cross-correlations, image and spectrum retrieval, etc. It is used under the hood in a number of the archive's infrastructure, but also has an expanding set of interfaces for scientific users. So we hope it'll become your new favorite Pythonic way to get the data. You can take a look at the documents, the help pages on readthedocs.io. I would like to take a moment to compare AstroQuery and Pyveo. And in short, they are complementary. AstroQuery often uses Pyveo under the hood for its standardized interfaces. AstroQuery is archive specific, though, and can include specialized functions that work only for that archive and depend on that archive. Pyveo is general and should work the same everywhere that the VO is implemented. So what is the Pyveo workflow? Whether you're running interactively or in an automated script, or more realistically, an iterative combination of the two, where you get something working interactively for a subset of the tasks and then launch it as a batch job. Either way, the basic steps are, step 1, you search the VO registry for services. The registry is where the archives publish the fact that they offer access to what data, through which services, and at what address. So you can search the registry asking, where do I get UV images or the latest Gaia catalog? Step 2 is then to ask each service about what it has. So if you're looking for UV images and found one or more likely looking services in the registry, you can then ask each one if that service has a Swift UVOT image of SEN-A. Or you can ask a service providing the Gaia DR2 catalog what columns are available to query. Step 3 is then to actually access the data. So for example, to visualize the images, or to perform a cross-correlation against your catalog, or to download the data. So finally, we get to the code. Here is a simple example of what this looks like in Pyveo. We have a snippet of code that's going to try to find all of the available images of M51. So step 1, query the registry for image services using Pyveo's function regsearch, asking for services of type image. And the resulting object is basically a list of services that you can then iterate over. Step 2, for each one of those image services, you then ask it whether it has an image of M51. You can use the AstroPy coordinates representation of its position and give a search radius. The result of the search is a list of what that services has that matches your query and that you can then iterate over. Note that each of these results is not the data itself, but the information about the data and the instructions for how to get it. If this were a catalog service, this step would be different. For example, it would be asking what tables or columns are available. Step 3 is then to actually get the data. In this case, for each result, we get the URL to the image and download it. If this were a catalog service, this step might be a SQL query or a catalog cross-match whose results would be a table. The rest of this code snippet is also very important to note. Every query should be wrapped in a try-except statement because there will be failures. Some services may be experiencing downtime. Some services might not be giving entirely VO-compliant responses, etc. At each step, it's important to catch these errors and log what happened before continuing on to the next. In this case, a few services are not giving Pyveo a comprehensible answer for some reason, while the rest successfully downloaded images. But it's important to realize that these are living, changing archives. So, things to know. Each archive is responsible for its own backends, which are supposed to follow VO standards, but can sometimes have mistakes. When you find problems, we invite you to contact the archive itself. You can also ask questions on the Pyveo channel of the AstroPy Slack space. And likewise, each archive has its own independent server issues. Sometimes the server may be down for maintenance or just slow to respond due to overload, for example. Again, you can contact the archive and always enclose your queries in exception handling and logging so that you can figure out after the fact what you got and why. Each of these is a living archive that changes as a function of time. Sources are added, data are reprocessed, and so on. So queries that you ran yesterday may not give the same results today. The VO is always evolving and growing. So this was the introduction to a workshop that we ran last week and that you can then essentially run for yourself now. We've developed a set of notebooks for you to work with to learn how to use these tools. You can download them from the GitHub repo shown here, or you can run them in a temporary session in the cloud by running a session in My Binder using the button at the bottom of that GitHub page. The contents of this repository start with a quick reference notebook with one example of each type of search. And then there are two notebooks that run through different science use cases. The first one demonstrates how to inspect a list of candidate objects using multi-wavelength imagery. The second guides you through preparing a proposal on a given object by looking at what observations have already been made. And each of these science use cases uses the methods in the quick reference in different ways. And there's also a set of detailed cheat sheets for each type of search, giving multiple examples with different inputs. Lastly, there's a known issues to consult when things don't go quite as you expect. So now I'm going to stop sharing my slides and instead share with you a view of these notebooks. And first, our webpage that the NAVO Astronomical Virtual Observatory's webpage, where we describe the purpose of these notebooks and these workshops and give you a summary of the different materials that are available for you. I've already got these downloaded. You can, of course, go download them yourself or run them. I just wanted to give you a quick view of what they look like. This is the quick reference notebook. There are instructions if you're going to run this on your own machine for how to set it up correctly so that these will run. And some descriptions of the terminology we use about the virtual observatory and the different services: image services, registry services, cone searches, and table accesses. So after the imports, the first step, as I said, is always searching the registry for what is available. We also give in this notebook a few tips for how to use the search function in the registry most effectively to find what you're looking for. And then tips on how to look at the results, which are AstroPy table, can be converted to AstroPy tables and visualized this way. And then we give an example of each of the type of searches that you can do. A cone search, which looks for objects in a given region. An image search, which downloads, shows you how to download an image of your object, which you can then visualize. Spectra, likewise, and table searches, including cross correlations with catalogs that you can upload yourself. So all of this is run through very quickly in the quick reference and in more detail for each of the types of queries in the cheat sheets. The science use cases are actually maybe more helpful to you because it shows an actual scientific task that you want to accomplish and how you do that. And so in this case, we're preparing a proposal on a source and we want to find out what observations have already been made on this source. So again, we want to find some previously quoted chandrafluxes. We start with the registry search and look for information that has been published on this already. We want to make some images, for instance, ultraviolet and X-ray images. So we look for image services, get the results, all the images that have been taken for that particular object, and you can download and visualize them. And this continues on to making a spectrum and what you can do with that, although that usually requires more specialized tools to analyze it. So I'm going to go back to my slides just so that I can put up for you the URL again so you can get to it. And so again, here at the top is our NAVO support page. And it links to our workshop materials, which are then the next link on GitHub at NASA NAVO workshop. And at this point, we'll take any questions you would like to ask. We hope maybe there will be some people who are at the workshop and have already played with these. Otherwise, you can ask specific questions about how you would do, whether you can do a particular scientific use case, etc. Any and all questions are now welcome.
Thank you so much, Tess, for that. Like she said, now it's time to ask questions or comments. You can put that in the chat, or you can unmute yourself and ask out loud, just whatever you guys want to do.
I have a simple question. So I'm interested in using this for like a non-science major astronomy class with people who do Python. Are there like some simple examples that are useful for that, for complete novices, basically?
Well, the two science use cases there are not very complicated, and you could easily adapt them to something else. I think so. Yeah. In fact, we've been told we need to do far more different use cases because the ones that are there are actually fairly straightforward. So yeah, I think this could be used. Although I would caution you and your students to remember that you might run into issues with different services giving occasionally odd results.
Also,
that's the one disadvantage, and the advantage of this is that they're very heterogeneous, the services, and the VO basically ties them all together with one standard interface. But under the hood, they can be very different, and some of them have really good metadata for describing what they're giving you, and others have less good metadata.
Also, if you have ideas, like specific ideas for something that you would like your students to go through, we are in the process of planning future tutorials that we'd like to make available. So we could certainly talk about that.
Like, would be nice if, for example, to make a Hertzsprung-Russell diagram of some stellar cluster or so, you know?
Yes, I will put my email in the in the chat.
I'm gonna write that down.
I have a quick question.
Yeah, go ahead.
Yeah. Okay. So I'm very delighted to hear that VO is a thing again. For a while, the VO was kind of dead or something. And so, what is the status at the moment? I know that the international VO is still happy and alive, but I wasn't aware of the development on the US side here.
Well, it never died for us, and the NASA archives have been making our services VO compliant for a while. I think that one of the things that's happening now is that it's finally reaching a sort of critical mass that it's going to be useful. I don't know if any of the others want to say anything who've been involved with the VO for longer than I have, but that's my impression.
Bernhard, are you asking about the funding?
Implicitly,
so,
yes.
Yeah. So NSF was funding the VAO or the VOA. I always get confused. For some time, and that funding ended, and NASA decided to fund the NASA archives to continue the VO effort amongst ourselves. So it is a smaller effort, but based more on actual archives that are implementing, that are serving data. So I don't know if that answers your question better.
Okay, well,
I agree with all that. I'd just like to add that we do have some other partners in the US that are not NASA funded that are very active. The Rubin Observatory, for example, is very active in making sure that all their data will be available via these virtual observatory protocols, in fact, primarily for many of their search use cases. So they're sort of a heavy hitter in the environment, and it's great to have them with their new use cases and so on to help keep the interfaces fresh and relevant. And also the CFA is closely involved in all this.
Mm-hmm. Yeah, I'm aware of quite some effort on the European side at ESA in Spain. And,
yes, very much.
Right.
If you've done a Gaia query, you've used the Virtual Observatory, for example.
Exactly, yeah. And so they also, they have been working on a standard for observatory visibilities and observatory.
Yeah, that's right.
Observation availability. Are you doing anything in that area? Are you working with those guys as well?
the individual observatory operators are looking at, certainly the Hubble and JWST missions where I work are looking at that, and will likely make their information available through both the visibility and the sort of duplication checking features available through those interfaces. Absolutely. Okay.
Because I'm trying to get my colleagues at Sophia to buy into that as well.
Right.
Okay, Bruce,
Other
I see your
questions?
hand. Bruce can go ahead.
Okay, thank you. To respond to Bernard a little bit, I think that the IVOA, the VO, it now has gone beyond critical mass in the astronomical world. I would recommend you read a paper that I wrote as part of the proceedings of ADAS 30. It was called the International Virtual Observatory Alliance in 2020, which describes all the activities and all the take-up of the IVOA in the past year, essentially from the point of view of science services. So I can send a copy if you like, but if you're interested, I recommend it to you. Also, another project in the US that Tom didn't mention that has made big use of VO standards is the data labs at NOIR labs.
Okay, yeah. If you could send me that paper, that would be really useful, I think.
Okay, I can do that.
Thanks. I have another question, if I may.
If there aren't any other questions, I haven't looked at the Slack. Nope. Go ahead.
How version dependent is your interface here?
Well, the VO standards evolve slowly. So
I meant
in that
Python.
sense, they are not meant to, the Python code itself. Well, like anything in Python that's being developed, it's getting better all the time. Let's put it that way.
Okay.
Yeah,
it is very much under active development.
Yeah, it is. For these workshop materials work with Pyveo version 1.1, Python 3, and I mean AstroPy 4.1 or later is kind of best, because Tom Donaldson fixed something with byte strings in the AstroPy VO table. So it's been pretty stable, yeah, like over the last year. But yes, more development is happening.
We've got a question in the chat box.
Directly from catalog. Okay, can you make a multi-wavelength from radio to gamma ray spectral energy distribution of a source directly from catalog fluxes? That would be a very good use case as well. So yes, in principle, you should be able to do that. It might take a little bit of work to understand each of the catalogs and the information you're getting from each of the catalogs, because it'll very much depend on exactly what numbers they are using to make sure that you're comparing like with like to construct your SCD. But yeah, actually, that's a good use case. We can add that to the list too.
Yes, and if it's an extragalactic source, I think NED might have it already. NED is one of these NAVO archives.
Oh, yes. NED has a service, SCD service. Because we already collated the data from different journals and some of the survey catalogs. There's a cross match for you. So if you go to NED search, if we have the data, you'll get it. There's a VO service, SCD service. You can go to that homepage under the information help, find the API call, or you can just search on object. If you know the name or position, then there will be a detailed photometry/SCD page in the tab. You can click on that and see the plot and the data at the same time.
Well, it sounds like this is a use case we should make. And we
I
should
just
do it
added
for,
it, yeah.
Oh,
Yeah.
okay. Yeah, we should do it for a stellar source too.
Yeah, exactly.
Santiago, if you have more questions, you can come to our, come to the Slack, and I can give you a demo, not demo, if you're interested.
One more question just posted. Follow up on the SCD use case. In terms of radio, one would need to have the UV range sampled for any given non-point source to know if it can sample the flux. Is that information captured? Well, that depends entirely on who is publishing the catalog. I don't know specifically anything about such radio catalogs and what information they provide. Anybody else here familiar with that?
Yeah, I don't know.
I mean, non-point sources are always tricky.
Yeah, I was going to ask that too, because so that's the hole in the development, I suppose, still, to be able to control the area that the flux is coming from in those searches.
Yeah, but that's more of a detailed analysis. A detailed analysis you would do of a given data set rather than a VO task.
Yeah, if the archive or observatory has created a catalog with that sort of information for specific sizes, then that may be a product that's available, but otherwise the analysis of the larger data products would still be necessary.
But the VO can still help you because it can get you the images on which you would need to make the measurements.
Mm-hmm. Looks like we're about to be cut off.
Yep.
So I'll just suggest that people can come to the AstroPy booth tomorrow at around 4:30, 4:40 if they have questions. Definitely encourage you to try out some of the stuff in the notebooks, especially check out at least the quick reference. You can see examples of this working.
All right. Thank you,
Right.
guys. Thank you, Tess.
Thank you so much.
Thanks, everybody.
And like they said, you can visit their Slack channel or their exhibit booth for any further discussion.
Yeah, you can also stop at IPAC archives booth or channel, Slack channel, and ask questions on this too.
Sorry, guys, I forgot to mention that.
It's fine. You did a lot already.
Every time I do this talk, I get rougher because I get bored with it.
Thanks so much, guys. Unfortunately, I have to end this one so I can start.
Go ahead.
Okay.
Bye.
Bye.